Greetings, this is Eugene the Philosopher, the greatest living philosopher after the unfortunate passing of Quentin Robert de Nameland, who obviously has been the greatest living philosopher before me. Now in this video I would like to talk to you about the cult of Einstein and Hawking. Now why did I use this strange construction as N-stein? Hopefully would become clearer near the end of this video. So yeah, now an important caveat right at the beginning. So I wouldn't be speaking about Einstein and Hawking as real people, but rather I would focus on like public perception of them, of these people, like their image in the media, in the the public discourse, and of their achievements also, right? So yeah, there's that. And in case you would be very lazy and wouldn't watch this video in full, like basically what I'm going to be talking about is the contrast between the real achievements of Einstein and Hawking, which are very modest, to be honest, and their perception in culture as these geniuses, these great people, etc., etc. So I'll try to examine the achievements themselves firstly, and secondly, this public perception of them, and we'll try to examine the possible reasons for this disparity between them, right? So this is what this video is all about, basically. So yeah, as I've noted in my video about homage to Einstein, basically words like genius, great man, like a like a prodigy, they're all like synonyms for the name of Einstein today. And I believe what follows next in this video would show you that there is really, it's like a fruit of some sort of advertisement, almost like a meme in Dawking's terms, some like an idea which, like a virus, spreads all over the culture, even though it's almost like a hollow shell. It's kind of empty inside. So, and the same story happened with Hawking. Like after Einstein's death, like maybe a couple of decades later, Hawking became this sort of paragon scientist, so to speak. So this baton was passed to him, metaphorically speaking. And but in case of Hawking, I believe there is even less achievements than in case of Einstein. But again, we'll talk about that in a few minutes. So as follows from my homage video, I believe you could clearly see how much of Einstein's achievements are really almost like a feeble imitation, or almost like direct plagiarism. Like basically the very same works were done by other people, but somehow they're attributed to Einstein alone. And all these other people are virtually unknown in mass culture, whereas Einstein kind of shines like a brightest star in our sky, so to speak. So, okay, so what Einstein really did, like what are his achievements? So in my opinion, there are only basically two of them. So one of the things he did was, again, like for example, special relativity was basically developed by other people, people like Hendrik Lorentz, Henri Poincaré, and some others. But what Einstein did was he kind of reinterpreted this theory, reinterpreted, say, Lorentz transformations in such a way that to get rid of ether, basically, right? So Lorentz transformations actually follow from the existence of ether, etc., etc. But Einstein said, well, we can have the same transformations without ether too. So these two interpretations are absolutely equivalent in physical sense. I mean, in the sense of their results, the existence of ether and non-existence of ether. So Einstein kind of propagandized this position that the ether does not exist. But again, all the conclusions would be the same anyways. So yeah, that's what he did in special relativity. And in general relativity, what he did was that basically, again, all the same equations were derived by Hilbert, etc., etc. And they might be derived based on, flat space-time, Minkowski space-time, whereas Einstein says, well, no, gravitation is all about, geometric, basically kind of like distortion of space-time, right? So he proposed this geometric interpretation of the equations of general relativity, whereas you can have the same equations just by saying that no, it's not the space-time itself that changes, but it's the, you know, the fields that change, basically. And I believe that even Hilbert, the other guy who derived the same equations, he kind of also thought that they might be interpreted geometrically, basically. So this is not even Einstein's kind of own idea in some sense. Okay, and by the way, speaking about ether, for example, it had to be reintroduced later, actually, you know, in quantum field theory, where we talk about the electromagnetic field, which is basically a synonym of ether, right? So even that idea kind of failed in the long run. And in general relativity, again, like Poincaré himself stated that, well, you know what, we can actually use any kind of space, any kind of space-time we want. It all depends on how convenient it would be, right, for us to use it. So you can have general relativity with flat space-time, Minkowski space-time, and you would be pretty much okay. So in this sense, Einstein is also kind of wrong, you know. It's only one of the possible interpretations, what he proposed. Of course, he had some other works, like he used Planck's hypothesis to describe photoelectric effect, for which he got Nobel Prize in, I think, 1921, but I might be wrong here. But again, it's Planck's hypothesis, not Einstein's hypothesis. It's the experimentalists who derived all these laws of photoelectric effect, Stoletov and many other people, etc., etc. So it's also a very modest contribution, to be honest. I mean, sooner or later somebody else would have come up with the same idea, like let's use Planck's hypothesis and photoelectric effect. Then he had also some minor works in statistical mechanics, in theory of lasers, etc., etc. But they were also kind of like imitation-like, so not very serious, to be honest. But again, in Hawking's sense, in Hawking's case, excuse me, the real achievements were even less than that. Like basically, what Hawking did, he continued the work of Jacob Bekenstein, another N-stein here, right? And Bekenstein proposed to consider black holes in thermodynamical sense. So he proposed to use, you know, the mathematical apparatus of thermodynamics to describe black hole behavior. And that's what Hawking did following Bekenstein. So it wasn't his original work. And more than that, like the very famous paper of Hawking, you know, about the from which it followed that so-called Hawking radiation should exist. You know, black holes should emit because near the event horizon, the virtual particle, the pairs of virtual particles would separate, and one of the particles might fall beyond the event horizon, but the other one would be emitted in that case, which is called Hawking radiation today. But it's not even Hawking's idea, you see. Soviet physicists Zel'dovich and Gribov, they've proposed this idea, but they were discussing it, but they thought it's a stupid idea, basically, so that's why they didn't publish it. So, but Hawking was aware of that, and he actually acknowledges that this idea comes from these guys. So Hawking visits Moscow in 1973, and lo and behold, in 1974 comes his paper gets published, where basically this idea is stated, and he becomes famous for that, right? So what a coincidence. But anyway. And speaking about Zel'dovich, like if you watched he actually was born in my hometown, which is kind of neat. And he's one of the most decorated scientists in Soviet Union, mostly for his work, you know, in various shady institutions. I mean, basically nuclear bomb, etc., etc. He was working a lot with nonlinear phenomena such as combustion, etc. But anyway, so If you watch the movie Interstellar, you might notice that when this woman, I don't know her name, sorry, when she writes on this blackboard some equations, right, you can notice there are tensors, field tensors, I think, or whatever, with indices, Cyrillic indices, Ya-Be. So these Ya-Be, it's actually the initials of Zel'dovich, because he was Yakov Borisovich, which is Ya-Be. So it was Kip Thorne's kind of way of, again, paying homage to Zel'dovich, basically, and for his contributions to general relativity. Okay, so basically the only achievement of Hawking is this proposal, which is not even his proposal in the first place, of the hypothetical radiation of a hypothetical object, right, of a black hole, because we haven't seen any black holes, right? So this is another topic, and even more than that, like, it's not only just hypothetical. We cannot even detect it because it's very weak. Like, if you calculate what kind of radiation would follow from a black hole with a solar mass, one solar mass, the temperature of this radiation would be like orders of magnitude lower than even the temperature of the so-called cosmic microwave background, whatever the hell that is. I mean, if you know about Pierre-Marie Robitaille's theory, it's not even primordial cosmic radiation, but whatever, doesn't matter here. So this radiation is almost by definition cannot be detected, right? So this is it's kind of just ridiculous. Maybe that was one of the reasons why Gribov and Zel'dovich kind of forgot about it, but I don't know. Again, that's kind of like a separate topic. We might use other instruments to try to evaluate how much actually Einstein and Hawking contributed to science itself. For example, we might use this standard H index, Hirsch index, which is basically, well, it's like the more your papers get cited, the bigger your H index is, which kind of is a secondary way of measuring your impact onto science, right? How many people used your work in their work, basically. So, and if you look at H index of Einstein and Hawking, you will see that, according to Google Scholar database on April of 2019, Einstein was only 46th in all the world, in the whole list of all scientists, and Hawking is 880th. So yeah, they're not very influential. Like, I'm almost sure that you haven't even heard about most of the people who are above Einstein in this list, right? So there's again a clear contradiction. Like, why do we even know about this guy? And by the way, so one of the probably main reasons why Einstein is so high there is because of the so-called EPR paper, Einstein, Podolsky, and Rosen. So it's not even purely his work, right? It's these two other guys also contributed. This paper has 18,000 citations, or about, so maybe 17,000, which is kind of a lot, but at the same time, it's not as much as, and the other papers of Einstein are cited much less frequently. Like, they have maybe 5,000 other, the runner-ups, so to speak. But that's not even that much if you think about it, because if you look at areas like medicine and biology, where people just keep citing each other all the time, like some of the papers in these areas have like hundreds of thousands of citations. So that's like order of magnitude more than what Einstein had. But I'm pretty sure you don't know many of these scientists, right? So even that measure shows us that no, these guys aren't actually that great, in some sense. And by the way, the first in this list of H index is currently Michel Foucault, the French philosopher. Well, it's kind of funny because he's not even a scientist per se. Like he's more of a philosopher again. In some sense, like if you use criterion like Popper's criterion of falsificationism, you can even say that Foucault is actually a pseudoscientist, you know, which is kind of funny. And Popper himself is actually 837th in this list, so he's much lower than Foucault, but higher than Hawking, right? So there's a clear contrast between achievements of these guys, Einstein and Hawking, and their perception of their achievements and their personalities in the mass culture, let's say. So what is like the sources of these of this contrast, of this contradiction? So perhaps one of the sources in Hawking's case, at least, was that he actually worked a lot with, you know, popularizing science. His famous book, Brief History of Time, is like one of the sort of like a trend-setting works in this whole area of popular science. And people like Neil deGrasse Tyson, you know, Michio Kaku, Bill Nye, all this Discovery Channel, all of that culture kind of draws its power a lot from this book in particular. Now, obviously, we've had like other popularizers of science, people like Carl Sagan, who kind of worked a little bit before Hawking, but they've actually worked at the same time later. But anyway, I'll mention Sagan at the very end also with regards to other things. So yeah, this definitely impacted Hawking's reputation, like it made him visible, so to speak. But the other reason in his case was definitely disability, obviously. Like, you know, he's perceived as some sort of, you know, like almost like an oracle, almost like not entirely human, you know, in some sense. He's almost like a saint, some queer creature that kind of, you know, entered our realm from some divine areas, and it kind of has this connection to this divine light that shines upon it, so it can speak from God, basically, right? So there's that sort of thing. And disability definitely is one of the primary kind of like instruments of achieving that perception by public, right? But again, I'll mention that a little bit later. Then we might look at actually the, you know, genealogy of all that stuff, on history, basically. So if we look at 19th century, we've had this, you know, strong industrialization, which kind of brought many new problems, you know, many new paradoxes, etc., etc. We've had this, you know, growth of hybrids, what Bruno Latour calls hybrids. See my video about pseudoscience, I guess, where I've kind of discussed that in a little bit more detail. There's, you know, this famous story about young Max Planck, who was going to basically study physics, and a dean at the university said to him, well, why are you going to study physics? Basically, we have solved most of the problems in physics, like we only need to have some, you know, minor tweaks here and there, and we'll know everything. But after that, look what happened. I mean, we've had all these scientific revolutions. Again, one of them was actually connected to Planck himself, you know, the introduction of the quantization, etc., etc. So yeah, so it has become clear already at the end of 19th century that, you know, something is quite wrong in our understanding of nature, or at least something is not as simple as it seems, you know. We cannot, basically, modernity kind of have bitten a piece that it couldn't swallow, you know, in some sense. So a lot of problems appeared at that time, both in practical sense and in fundamental sense. So, and as a counter to that, some, you know, directly opposite tendencies appeared, like, for example, traditionalism, which is basically a denial of modernity in the first place. So traditionalism is basically also a fruit of modernization, because you don't even have a notion of tradition if you don't have modernity, right? It's the modernity that brings to life both the tradition that was before and modern society that kind of came after. Because if you live in a traditional society, you don't even have a concept of tradition, because everything around you is tradition, right? You don't have anything to compare it to. So you don't even know that you live in a traditional society unless you modernize and you kind of recognize your enemy, the tradition, as your enemy. And the traditionalists try to say, no, it was the modernity that was the mistake, but we need to return to tradition, and so on and so forth. And you can clearly see how there are many historical parallels in 19th and 20th century, I believe. Again, both centuries demonstrated to some degree this doubts in the very idea of progress, some decadence in culture, in art especially. You might say that in some sense Marquis de Sade was kind of, in the early 19th century, was kind of an analog of Aleister Crowley in the early 20th century. There are many parallels like that you can draw. And even late 19th century with Friedrich Nietzsche is kind of an analog of late 20th century with, postmodernists, basically, who kind of just repeated what Nietzsche said in many respects. And you've had, utopian thinkers like Saint-Simon in 18th century, like late 18th century, and Marxists in late 19th century, etc., etc. So these are all kind of the consequences of more or less the same type of cultural dynamic that just enveloped itself, kind of evolved, so to speak, throughout these latest 200 years, last 200 years or about so. And in 19th century, you've had Napoleonic Wars, which kind of basically shook all the world, not only Europe, but obviously the Americas too, etc., and some other parts of the world too, which brought forth this romanticism, in art, in culture in general, where people tried to escape to some, true nature, like to this dark and kind of violent version of nature, these passions and things like that. But at the beginning of 20th century, again, with all the major wars, like First World War and then the Second World War, we've had the same tendencies. Like after the First World War, there was definitely a desire of escaping to somewhere. The nations in Europe and to a lesser extent in Americas, they were very tired. They wanted to escape from the world because the war was just horrible, and people didn't want to see that anymore. So a lot of primitivist tendencies appeared, surrealism, Dadaism, all that kind of stuff. It's exactly the fruit of the Great War, and I believe that it was one of the most important factors in accepting these very counterintuitive theories, such as quantum mechanics, relativity theory. So they were so detached from our regular intuitions, from our everyday experience. So that was exactly what people wanted back then, to escape into some surreal thing, to kind of relieve the pain, in some sense, to have a hypnosis or a sleep in some sense. But at the same time, the acceptance of these weird theories have led to a change in the whole scientific discourse, a change in the way scientific journalism worked, because since then, the introduction of quantum mechanics and relativity, the caste of scientists have become somewhat isolated from the world. It kind of built this cocoon around itself, where the like entry was very hard. Like you've had to learn all this complicated maths. You've had to kind of break your intuitions a little bit. You've had to forget about philosophy. One of the, I believe, most important things that have happened in science is it's like the banishment of philosophy from physics. It was a really major turn, and it happened roughly at the beginning of 20th century. But anyway, so scientists have become almost like priests. They have this isolated community where they develop all these counterintuitive stuff, but if they want to talk to society, they need to go outside, and they need to kind of preach there, almost like priests did back in the day, and that's exactly because the truth, kind of the accepted version of truth, became so complex that it's beyond everyday experience. So you need a sage, you need a priest to give you an idea of how world really works. So you kind of listen to these scientific gurus that kind of teach you how the world actually is, etc., etc. So yeah, it bears a lot of similarity with proselytization, in religious terms, and this is one of the reasons why I call this a cult, because it has a lot of parallels with indeed, like a cult. Basically, it's not an exaggeration. There are really strong parallels. Like if you look at Lemaitre, who basically introduced the idea of a Big Bang as just an attempt to scientifically prove the act of creation by God, etc. So it's really kind of a bizarre turn of thought. But anyway, yeah. So, and one good analogy I believe that we can have here is radio. In radio you have like one emitter, like this community of scientists, like huge tower, that sends radio signals everywhere, and you have a lot of receivers, the society, which is kind of atomized, and cannot really resist this signal. They can only listen, and they cannot send the signal back. It's one-sided conversation basically, and it's a complete. And by the way, the appearance of radio is very, very strangely coincides with the appearance of these, totalitarian regimes, fascism, like quasi-fascism of Roosevelt in America, etc. The Soviet Union, basically, same story here. Like all the world was under totalitarian rule at the beginning of 20th century, pretty much, I would say, and even in the middle. But anyway, so yeah, so this is like the metaphor of radio, right? Which kind of was adopted even by science since the beginning of 20th century, roughly. But before that, you can have a metaphor of letter, this famous republic of letters of 18th century, 17th century, where basically you've had these horizontal connections of multiple scientists who've been discussing their ideas with each other, basically as peers, But this system of letters kind of broke and was substituted with the system of radio, with this signal that's been just transmitted from this closed community of scientists. Yeah, and it became only worse with Cold War after World War II. Because basically what you've had then, we've had, nuclear arms race, space race, and the main societal institution that was kind of organizing science was became these large institutions, the academies of science, big institutes like Los Alamos Laboratory, CERN, some Japanese institutions, same story with USSR, etc. So I think it's beyond doubt that you cannot have openness and any sort of peer discussion in that sort of system, right? It's completely cocoonized, so to speak, just because of the way politics worked at that time, etc. And it's actually interesting how these marginal theories such as quantum mechanics and relativity became dominant in the end, right? It kind of definitely bears an analogy with Christianity, if you think about it. Like, Christianity was basically a small sect of Judaism when it appeared, but then it was kind of adopted by this huge empire and have turned into this dogmatic church, whereas at the very end it was a very anarchistic sect, but we'll talk about that a little bit later, about this anarchism and early Christianity and analogies with science later on. But okay, so all the major governments have made some moves to actually in some sense legitimize relativity and quantum mechanics. Like, even Nazis acknowledged relativity in 1940. Soviet Union, basically right in the middle of the war in 1942, they've acknowledged relativity, but in 1964 they've even actually directly banned any theories that would contradict relativity theory, which is not very healthy if you ask me, but again, it's the way science was organizing at that time, right? So I think you can say that in some sense Einstein and Hawking are saints of the Church of Science, So let's examine some of the basic ingredients of this, what I call cult of N-stein and Hawking. And those would be, firstly, it's a cultural ingredient, where, again, as I've said, people were tired of the war. They needed escapism. They needed something, pure in some sense, but at the same time something mesmerizing, hypnotizing, some pacifism, Then definitely one of the reasons was sociological, where, again, you've substituted religion with science, right? So instead of this caste, of this class of priests, you now have a class of scientists, and they naturally tend to form these hierarchies, just as everything else in nature does, right? So this was one of the, and this cult was one of the instruments of building these hierarchies in sociological terms, in scientific communities. Then one of the important ingredients was media. Basically the tool for marketing ideas would be, again, to kind of appeal to this authority of Einstein, Hawking, whoever else. Then people needed kind of some idols in the service of government, right? So since Einstein and Hawking, they were working at these large institutions, it kind of was like a role model for scientists in general, right? You don't have to be a free thinker. I mean, it's not appreciated if you be a really free thinking person, but it's appreciated if you would submit yourself to these hierarchies of power, right? Then definitely what I've already mentioned was the religious ingredient, where since now you have science instead of religion, well, again, you need some preachers, you need some saints, you need some, again, role models, etc., etc. And Einstein and Hawking are perfect in this sense. So yeah, and I believe this is not an exaggeration, again, when I say words like cult. There are so strong, very strong parallels here between, religion and science as it was unfolding in 20th century and later. And definitely one of the properties of cultural perception of Einstein and Hawking is they're kind of like the public receives them almost like wizards, you know, almost like shamans or, you know, wolves or saints. So they're kind of like these strange and queer people that have this, again, connection to the divine because they are strange, you know. They're not exactly human in some sense, right? They're like anomalies. So like, you know, it's a very old idea, you know. It's somewhere in subconscious, I believe, that in order to have connection to the divine, you have to be strange, you have to be queer. Like, for example, you know, all these legends, all these myths about rituals that you've had to accomplish to become a shaman, to become a mage. Like in Persia, it was considered that a mage can only be born from incest, which is, like, again, super unhealthy and super strange and queer, but that's how you get so strange, so that you can have this connection to the divine. Or in Siberia, where shamans needed to, like, sleep for a year in some trunk of a tree. So this sort of, it supposedly kind of transgresses you, it kind of throws you so far away from, you know, the regular everyday life, that you have to be like these, you know, divine powers would kind of just stream onto you just because you're so different, you know. Yeah, okay. and like, I don't think I need to bring up, you know, all these strangenesses that are attributed to Einstein. There's, like, literally whole books written about this. And again, like, most of it might even be mythical, you know. It might be just some people, some rumors, fantasies, whatever. It's just the way these kinds of people are perceived by the public, basically. And in case of Hawking, you don't even need to invent anything. I mean, just look at him and you'll understand that he's not exactly a regular person in the first place, right? And here I think I would like to mention this idea of Nietzsche, that, you know, a genius, like, when you call somebody a genius, what you really mean is that, you know, he's from a different league, you know. There are regular people and there are geniuses. And like, so when I call somebody a genius, I kind of come to peace with the fact that I'm much worse than this person, you know, at least in some respects. Like, I'm saying, well, okay, he's just a genius, you know, we don't have to compete. So I can retain my self appreciation, right? Even looking at how bad I am, you know, in comparison to this genius. So yeah, there's that interesting idea. So as a result of all those ingredients that I've listed, you know, these historical factors, etc., we get this cult of authority of Einstein and Hawking. We get this extreme media popularity of them. They're incredibly well recognized. Like again, they're like symbols, you know. They're like totems in some sense. And it goes as far as to, you know, like the very idea of what a scientist should look like, you know. He should look like, again, this savant, you know, almost like this saint, kind of sort of autistic, weird, creepy guy, or something to that effect. And one of the other results of this cult was the, again, usurpation of other people's achievements. Again, see my homage to Einstein video, where I show how many achievements of other people are attributed to Einstein almost like by default, whereas you can clearly see that it's not his work, right? Even the very, you know, titles of all these things, you know, Lorentz transformations, Poincaré's relativity principle, Planck's hypothesis, etc., it kind of screams in your face that it's not Einstein who had come up with all that, and so on and so forth. But again, you have this public image of some saint, of some savant, etc. And with the introduction of television, you know, this and you know, just, and obviously internet afterwards, we've had this culture of talk shows, you know, with its kind of mood of you know, this almost like a freak show. So definitely this also helped promoting this idea of queer people, these savants slash saints, these, you know, weird query guys, etc., etc. And another interesting property of the cult of Einstein and Hawking is that, well, it's again, it's very characteristic that they both work with hypothetical or irrelevant objects and relations. You know, again, things like Big Bang, black holes, like Lorentz transformations, whatever. Like, it's almost like pure theory. It doesn't have any applications whatsoever. Like, again, what I've said about the interpretation of special relativity by Einstein, where he gets rid of the ether, but it doesn't matter, like, literally, because you would have the same conclusions with ether and without ether. So in some sense, it's irrelevant, right? Or general relativity can have the same equations where you have a geometric interpretation of gravitation, or you have a field interpretation of gravitation. So it's absolutely irrelevant, etc., etc. And Hawking, like this hypothetical radiation that cannot be observed of a hypothetical object, right? It's just ridiculous. Like, how's that gonna help us, right? So, but in public perception, this is exactly what we need. We need these, you know, clean, pure beings of light that kind of work with this pure divine matters, you know, how many angels are on a, you know, pin or something on a pin tip. Like, they shouldn't be, like, you know, practice is very dirty. Experiments are very dirty, and then these divine creatures, they should not mess with that. They should talk about all these, you know, godlike topics, irrelevant topics, empty topics, right? So it helps a lot to retain this cult, right? Because these guys cannot be wrong, because, well, everything they work with is unfalsifiable in the first place. So yeah, and one of the good examples of that would be, you know, these black hole wars, the argument between Hawking and Susskind, Leonard, I think, Susskind, where, you know, basically the question, the argument was about whether the information disappears in a black hole or not. And the funniest thing is that neither of them gives even a definition of what information is. So it's like, from the very beginning, it's an argument about nothing, you know. It's a very, you know, almost like scholastic argument, kind of like what people had back in the day, in, I don't know, 13th century or about. So like, you know, this argument about universalia, etc., or how do you call it? I don't know. All right, and one interesting artifact, I guess, of the cult of Einstein was the cult of Tesla, I think, because it just kind of goes to show that even people who disagree with this, you know, dogmatic hierarchical structure of science kind of try to emulate the very same mechanics of power of their own, right? So they introduce Tesla as the sort of better saint, you know, than Einstein, and they say, well, yeah, Tesla is like the real saint, but Einstein is like a heretic, you know. But these guys say, no, your Tesla is heretic or whatever. But obviously, I mean, after Tesla, there were many other examples of that cultism of alternative sort, right? But it all boils down to political struggle, what I've described in more detail in my video about pseudoscience. Yeah, but it's just it's just painful to watch how much resources, how much effort people spend, especially these alternative scientists, on this political struggle, right? Instead of working on their own theories, kind of trying to refine them, etc., etc. They're fighting this evil mainstream science with Einstein as the kind of recognized idol of this mainstream science, whereas in fact Einstein is not even important for mainstream science in the first place, because again, it's just pure propaganda. Like, Einstein haven't really done anything. Like, it's like hundreds and thousands of other scientists who have built this hierarchical structure. Einstein is only like a spokesperson for it in some sense, right? So these poor guys, you know, these alternative heretics, they've been brainwashed by the same propaganda that kind of puts Einstein on a pedestal, and they think he's kind of important, right? So they spend a lot of time fighting him, and they have this illusion that if they would somehow demolish Einstein, like prove he was some sort of pervert or whatever, in that case, you know, they would demolish the whole hierarchy of mainstream science, whereas in fact, again, it's just pure propaganda and brainwashing. So yeah, it's really sad to observe that. But again, well, so during my historical rant, I've talked about, you know, the introduction of these huge institutions during, you know, the nuclear arms race and space race. But it's like the spirit of it is like 70s and 80s, right? But what comes next, and in modern day even, well, I would say that a certain erosion of this cult might be observed, like a certain erosion of this hierarchical structure of science. One of the, well, let's say, one of the reasons for that erosion is definitely, again, the introduction of the internet and social networks. And I've talked about that again in more detail in my pseudoscience video and somewhere else, in the video about Copernicus too. I've mentioned that. So in certain sense, this horizontal organization of science, you know, this Republic of Letters style organization of science is again slowly returning, you know, where you have literally a network, internet, where you have different views kind of interacting with each other, rather than just this radio-like structure of hierarchy as previously. So, but at the same time, we observe definitely a crisis in fundamental science. It's been noted long ago, like Karl Popper also wrote about it in the early 80s, actually. So it's kind of a well-acknowledged thing, at least among philosophers. Obviously, scientists are kind of more stupid, so not all of them can see that yet. There's again a crisis in fundamental science, but at the same time, the society focuses more and more on purely like applied science, on engineering, where you can have, you know, in certain sense, a cult of some technology or a cult of some material like graphene or something to that effect, or I don't know, like nanotubes, whatever. But you cannot have really a cult of a certain person in that area. It just doesn't work that way. So the machinery of this area is so complex and distributed that like a single person cannot maintain that, right? Because a lot of it also depends on market, and market is a inherently distributed system, right? Horizontal system, etc., etc. But that's a separate topic that I'm not really ready to tackle here. But anyway, this focus on applied science, it kind of relieves pressure a little bit from this fundamental part, right? So we can have various alternative theories right now to emerge, because in some sense society doesn't care about fundamental science anymore, right? It become very secularized in some sense. So even this church of scientism is already crumbling quite a lot, and it's easily noticeable. So we can have, like, just to name, like, literally off the top of my head a couple of examples, we can have these alternative theories of gravity, such as Verlinde's emergent gravity, you know, kind of entropic gravity. We can have McCulloch's theory of inertia, quantized inertia, that actually also relies on kind of like an analog of Hawking's radiation, which is actually Unruh radiation, etc., etc. So various alternative theories emerge, like literally right now in recent few years, and it's a great thing, I believe. Again, this maybe we're seeing sort of like a renaissance of this old school Republic of Letters type of skeptic science, you know. But again, there are a lot of efforts have been made to suppress that, and it's really clear. I mean, again, the topic of climate change, the Big Bang theory that absolutely ignores alternative theories, etc., etc. So there are many examples like that in modern world. But anyway, more and more scientists who actually are interested in finding the truth, which actually don't exist, but that's a separate subject. We'll talk about that later. So more and more scientists acknowledge that we need philosophy, actually. And they turn to these modern philosophers of science, such as, again, Bruno Latour, Andrew Pickering, Ernst von Glasersfeld, etc., etc., who have uncovered what seems to be like the real mechanisms of how science evolves, you know, continuing pretty much this line of, you know, Thomas Kuhn, again, Karl Popper, and all these other bright minds like M.J. Lakatos and people like that. So, yeah. So why do I put this N-stein in the title? Well, the idea was that, you know, Ein is one in German, so you might have Einstein, which is like a first iteration of this cultism of science. You might have Hawking as his descendant, as Zweistein in some sense, you know, the second saint, and you probably can have Dreistein and Vierstein and etc., etc., and, you know, N-stein and maybe N+1 stein, etc., etc. So yeah, kind of one of the questions I was asking myself when I was writing this essay on which this video is based was exactly that, like, who comes after Hawking? Because the essay was actually written in 2017 when Hawking was still alive, so it was a bit more relevant back then. And it's actually kind of symbolic that Hawking died on the day of birth of Einstein, you know, March 14th, which is also a Pi Day, you know, 314. Yeah, it's kind of really symbolic. I think you can have some conspiracy theory on top of that, maybe. So one of the ideas I've had that maybe some sort of AI might actually be Dreistein after Hawking, you know, because, well, for example, the AI like Golem in Stanislav Lem's works, kind of the AI that would act as this oracle, you know, this conduit of divine light, because obviously AI is not human, right? So it's different. So it might, in certain sense, play a role of this wizard and shaman, because it has something else to it rather than just regular human. So we might acknowledge it as something special. You know, it kind of reminds me of this Ultron from Star Control 3 and 2. The machine that Otwig had that kind of worked as their leader, etc. But yeah, this is a question that is still there. Like first of all, I'm not even sure that AI is possible, but again, it's a separate, very complicated discussion. But I don't think it's gonna arrive anytime soon. Like neural networks wouldn't create a real, genuine intelligence. because I strongly believe that in order to be intelligent, you need to be alive first and foremost. And until we wouldn't be able to create artificial life, we wouldn't be able to create artificial intelligence also. But again, we'll talk about that sometime later. Maybe in my video about aliens, or in my 3 videos, because yeah, I think I'm gonna make 3 videos because there's a lot to talk about there. Yeah, and one of the things I thought about like recently while I was preparing this video, which wasn't included in my essay, was that maybe, again, returning to this question, to this statement that today we're more focused on applied science, on engineering, etc., rather than fundamental science. Maybe people like Elon Musk, you know, actually play a role of modern saints in some sense, right? So Elon Musk is kind of like an N-stein of engineering, you know. He's like this idol of that area. But again, as I've said, it's due to its inherently market-oriented character, you would always have other people like in horizontal relation to these idols in engineering, like people like Jeff Bezos and all the other competitors of Elon Musk, you know, in sense of at least space exploration. But yeah, I would definitely say that Musk might be an idol of this focus on applied science, right? With his projects like, you know, this satellite internet, the rockets to Mars, electric cars, hyperloop, etc., etc. You know, the solar batteries on the roof, and many other things that he does. This is definitely like a servitude to this idea that we can have heaven on earth because fundamental science already figured everything out. We only need to apply it in a good manner, right? So Musk might be an idol here, I think. Okay, at some, yeah, I only have a couple of kind of unrelated comments here. Like, I think at some point Zweistein might have been Carl Sagan, actually, and it's very interesting why it was Hawking and not Sagan in the end, because they're very similar in many respects, and Sagan also has this aura of saintness to him. In some sense, so he's kind of like this, you know, autistic creature with divine light shining on his forehead. I think his relatively early death has helped that a lot. Like, he has this definitely this, I don't know, again, aura. I don't have any other better term for that. But I don't know, yeah, why it was Hawking and not Sagan at the end. And one other thing that kind of come to my mind was that you can interpret, you know, Einstein as American project because he worked in the United States, whereas Hawking is clearly a British project, you know, so maybe there's some conspiratorial competition going on in here. But with regards to that, again, Musk is very interesting because he's basically a British dude working in the United States. Well, he's not exactly British, I mean, but from the British Commonwealth, basically. So yeah, it's kind of an interesting dynamic. So I think it's time to conclude this very long rant. So the main idea of this video is that the actual achievements and contributions of Einstein and Hawking to science are incomparably smaller than the level of their recognition and praise they receive in like the perception of a regular person in culture in general, right? So in some sense they don't deserve to be recognized as all, you know, these geniuses, etc., because they haven't really done anything to do that, firstly. And secondly, there are like hundreds and thousands of other scientists who have actually achieved much more, yet they're almost unknown to general public, and this it pisses me off a lot. So this was one of the major pieces of motivation for me to making this video. But yeah, this was the main point, and I've tried to analyze what kind of reasons have led to this this contrast, let's put it that way. And there have been definitely historical reasons, such as, you know, world wars, and definitely there have been religious, cultural reasons, etc. But it's very interesting to observe just how the ensembles of power in scientific communities arrange themselves. And I believe that, again, the what I call the cult of Einstein and Hawking is a direct consequence of this natural arrangement of the ensembles of power in science. So, thank you for watching. The eons are closing.